Charles Collingwood. Today's adventure is in two parts. The first takes place in a laboratory here in New York, the other in Bali, an island in Indonesia. Yet both are equally strange. Each begins simply enough and ends in mystery, which is as it should be in adventure. You'll see what I mean, or rather you'll see what I'm saying, because this jumpy line which you see bouncing across your screen is made by an oscilloscope, a scientific instrument which takes the sound of my voice and traces the pattern of it. When I speak loudly, the pattern becomes louder. But when I whisper, the pattern changes again. This is the sight of sound. There's so many parts of me moving as I speak to you. There's such complicated changes going on in my vocal tract that this very sensitive instrument goes electronically crazy, vibrating in sympathy with my voice. Now, in a way, everything that we've said so far has been a preface to our adventure. We've merely tried to show you the ways that a picture can be taken of sound. At this point, we'd like to ascend into the rarefied air of pure research and show you some scientific experiments which don't have perhaps much to do with immediate practical problems, but are interesting just the same. This work is being done at the Haskins Laboratories. Here are three gentlemen who are concerned not only with the sight of sound, but with the sound of sight. Confusing idea maybe, but one which will become clearer in a moment. This is Dr. Frank Cooper, an engineer and associate research director of the laboratory. This is Dr. Alvin Lieberman, a psychologist on the staff of Haskins Laboratories and associate professor of psychology at the University of Connecticut. And this is Dr. Pierre Delotte, a linguist with Haskins Laboratories and professor of Romance languages at the University of Colorado. These three men and their colleagues are engaged in a very unusual problem concerned with the structure and the perception of speech. And they've built an instrument which we thought we'd like to show you. Dr. Cooper, just what is that equipment behind you?
This is basically a speech recording machine. It differs somewhat from most sound recorders, since this one records speech as a picture. The machine itself is called a sound spectrograph, and the pictures it makes are called visible speech by the Bell Laboratories people who developed this kind of speech recording. This is a light gun, and it exposes the photographic film, recording on it the analysis of the speech sounds.
Well, Dr. Cooper, would you show us some of these pictures of speech?
Why, yes. Over here is a viewing board, and on it we have a sentence, "Many are taught to breathe through the nose." That sentence was spoken into a microphone by Al Lieberman, and this photographic film was made from his voice. These are the words of the sentence, and here are the spoken patterns as they were analyzed from the sounds that he spoke. However, this is only half the story. That whirring noise that you hear in the background is made by a second machine. We call it pattern playback, and it converts these patterns into speech. Here's a copy of the sentence we just saw, painted on this endless belt. And here's how it sounds as the playback speaks it.
Many are taught to breathe through the nose.
Not high fidelity, but as research tools, these instruments have some very real advantages. However, it's obviously rather difficult to make a transmission in a room like this. Suppose I operate the machine while you ask Lieberman and Delotte to tell you a little more about what we are trying to do.
Okay, Dr. Lieberman, I'd like to have another look at that sentence. Would you mind explaining it?
Here is the picture that you just heard spoken by the playback. In this vertical direction, we show the frequency of each tone. That is, the number of vibrations per second. And in the horizontal direction, we show the passage of time. This is the way all languages look. No matter how obscure the dialect, the sounds of speech always make patterns that look essentially like these. But let's examine just one word. Here's the picture of the word breathe. Breathe. Now, no matter who speaks the word, essentially this pattern will emerge. The question we want to ask is, what are the really important parts of this pattern? We thought that we could find out if we could make all kinds of changes in the pattern and then listen to the effects of these changes. That is why the playback, the instrument that you just heard, has been such a useful tool. With it, we can draw simple patterns and then listen to them.
Now, let me get this straight. Do you mean that you just repaint these designs but make them simpler?
Yes, here is the simplified version as we painted it. In fact, it was this very pattern that Frank Cooper played for you a moment ago.
Now, would you mind going over this again, Dr. Lieberman, step by step? Or perhaps you could take another sentence and show us each of the steps.
Let's take this phrase, never kill a snake. Here it is, as it was recorded from my voice by the sound spectrograph. And this is what it sounds like when we put it through the playback.
Never kill a snake. Never kill a snake.
If we paint the pattern by hand, copying carefully, and preserving most of the details, we get something that looks and sounds like this.
Never kill a snake. Never kill a snake.
We shouldn't have expected much difference, since that painting was a fairly accurate copy. But now, let's hear what happens when the hand-painted version of the sentence is very much simplified, as it is here, and only the most basic parts of the pattern are included.
Never kill a snake. Never kill a snake.
And now, let's listen to them again in 1, 2, 3 order.
Never kill a snake. Never kill a snake. Never kill a snake.
Now, let me see if I understand this. The first picture was that of the actual recording of your voice. The next two were merely drawings progressively simplified from that. But who's doing the talking?
Actually, the machine is talking, turning these pictures back into speech. As you've just heard, the speech is quite intelligible, even when we throw away a great deal of the original sound, as we did here. And perhaps if Dr. Cooper will run this one through the machine again, but moving it very slowly, you can hear how the sounds change as the picture changes. In fact, you might like to see how some very simple patterns can be built up into speech sounds and words.
Here are some designs of the kind that Pierre Delotte was mentioning. These individual tones, when they are played at the same time, combine to give a major chord. As the chord, as it becomes musical, changes from music into a vowel, the vowel ah in this case. And if we make things change rapidly at the beginning and end of this vowel, I think that you will hear the word back.
Back.
This is the general direction that much of our present research is taking. Instead of starting from complex phrases and sentences, like those you heard earlier, we work now with only 1 or 2 sounds at a time, and try to find the rules for making each one. The word back that you just heard was synthesized by applying a few of these rules. Perhaps you might like to hear this word as part of a phrase, all of which was painted according to the rules that we've uncovered in our research.
Oh, my aching back. Oh, my aching back.
That's very appropriate. Well, did I understand you to say, Dr. Lieberman, that that phrase was painted by rule? Does that mean that when you painted that, you were doing it by theory and you weren't copying an actual voice?
That's right. By long, systematic studies of the sounds of the individual vowels and consonants in speech, we are now able to do a pretty good job of just writing the speech freehand without looking at the spectrographic patterns of an actual voice.
Then this is really synthetic speech. Do you have some other examples, Dr. Delotte?
Yes. Here is a rather strange one, which we made up some time ago to contain only the sounds that we thought we knew how to produce at that time. A big, bad man demanding money can kill you. Bang, bang.
Well, that's certainly apropos for television.
Here is the painted sentence, and here is the sound of it as played on the playback.
A big bad man demanding money can kill you. Bang, bang. A big bad man demanding money can kill you. Bang, bang.
Well, that's incredible. But let me ask you, when you say you draw the pattern, just what do you mean?
Exactly that. With a brush, some paint, and a piece of cellophane, we draw those patterns in this manner.
Well, while Dr. Delott is drawing, suppose we listen to a few more of those sentences.
We'll play some more like the very first one we played for you. These are like the hand-painted version of Never Kill a Snake, in that they are painted from actual voice patterns and represent some early tests that we made in an attempt to discover just how far we could go in simplifying the patterns and still have intelligible speech.
These days, a chicken leg is a rare dish. These days, a chicken leg is a rare dish. It's easy to tell the depth of a well. It's easy to tell the depth of a well. 4 hours of steady work faced us. 4 hours of steady work faced us. Never kill a snake with your bare hands. Never kill a snake with your bare hands. A large size of stockings is hard to sell. A large size of stockings is hard to sell.
Well, I can certainly understand everything that machine is saying, even though it does have an accent of its own. But tell me, if you don't mind, Dr. Lieberman, why did you pick such strange sentences?
Oh, they were taken from a test series that was developed at Harvard to test intelligibility under various conditions.
And the characteristic accent of your machine, how come it sounds so much like a machine?
One of the reasons is that the pitch of the playback's voice doesn't change. As you must have noticed, the playback speaks in a perfectly flat monotone. In a way, what we've done throughout is to remove inflection, emotion, and all individuality from human speech. That is a small but necessary step in our attempt to reduce speech to those really basic components that must be present if the message is to be intelligible.
Well, now, Dr. Delott, you speak with a slight French accent. Can you reproduce accents with your machine?
Yes. Let's take the word Alabama as it will be pronounced by an American and then by a Frenchman. Here are 2 hand drawings of this word. The top one is the American pronunciation with strong and weak syllables, and the French one, the bottom, is with more equal syllables. You want to hear the sound now?
Alabama, 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 Alabama.
I think that machine must have come from Birmingham. Well, we started this discussion now by showing you the sight of sound. Now, we've gotten around now to the sound of sight.
Perhaps it might be amusing to listen to the sounds that correspond to some common sights. Frank Cooper can run some pictures through the playback for you, just as he has been running these speech patterns. Here are some groups of geometrical shapes and the playback sounds that correspond to them. here is a kindergarten drawing of some ordinary scenes that one might well see while driving. Here's a walk, a farmhouse, the smoke from its chimney, and here the scene with all of its parts assembled. Transforming the geometrical patterns into sound is not merely an amusing trick. We like to think that it relates to certain rather interesting problems in the psychology of perception. And now, one more set of sounds from the playback. You will remember, perhaps, the pure tones and the chord that you heard and saw earlier. By drawing patterns essentially like those, we can try to produce music, though the playback was certainly not designed for that purpose. Here is something called Scotch Plaid, composed on and for the playback by our colleague Pierre Delatte.